One equation. 3 variables. Infinite unpredictability. And yet, a perfectly knowable shape. This is the Lorenz attractor. The point you are watching traces a path that is fully determined by a small system of equations. Nothing is random. And still, where the point will be 1 minute from now is, in practice, impossible to predict. How can both of those things be true at the same time? That is the question we want to answer. Not with metaphors about butterflies and tornadoes. With the actual geometry. In 1963, a meteorologist at MIT named Edward Lorenz was running a stripped-down model of the atmosphere on an early computer. He wanted to understand convection, the rolling motion of warm air rising and cool air falling above a heated surface. To keep things tractable, he reduced the entire problem to 3 numbers, changing over time, governed by 3 equations. The variables are not weather in any literal sense. The first roughly describes the speed of the convection roll. The second is the horizontal temperature difference. The third is the vertical departure from a smooth temperature gradient. 3 numbers. 3 rates of change. That is the entire universe inside this model. Lorenz was running this system day after day. One morning, to save time, he restarted a simulation from the middle, typing the numbers in by hand from a printout. He used 3 decimal places instead of the 6 the machine had stored. The new run started identically. After a short while, it began to drift. By the end, it had no resemblance to the original. A change in the 4th decimal place. That was enough to produce a completely different future. This is the property we now call sensitive dependence on initial conditions. The popular name, coined by Lorenz himself in a later talk, is the butterfly effect. But the butterfly effect is only half of the story. The half that everyone hears about. The other half is the shape. Watch what the point actually does. It spirals around one center for a while. Then, with no warning, it jumps to the other center and spirals there. Sometimes it stays a few turns. Sometimes many. There is no period. There is no pattern that repeats. The order of jumps would take forever to write down. And yet, every single point of the orbit lands somewhere on this surface. Never above it. Never below. Never outside the 2 wings. The point is wild, but it is wild within a fence. Try a different starting point. Anywhere in space. The orbit drifts, finds the butterfly, and joins it forever. The shape is universal. The path on the shape is not. This is what mathematicians call a strange attractor. An attractor, because nearby orbits are pulled toward it. Strange, because the surface itself has structure on every scale, a kind of fractal embroidery if you zoom in. Zoom in once and you see 2 sheets where you thought there was 1. Zoom in again and each sheet is 2 sheets. Keep going forever. The butterfly is not a surface. It is a folded set with no end of folding. That folding is the source of the chaos. 2 points that look like neighbors might be on different sheets. As the system unfolds those sheets, the neighbors are stretched apart. By the time the sheets are folded back together, the order has been scrambled. This is why weather prediction has a hard wall. Not because we lack data. Not because our equations are wrong. Because the system itself amplifies tiny uncertainties at an exponential rate, and there is no measurement precise enough to outrun that. We are not failing to predict the weather. The weather is, in a measurable mathematical sense, not predictable past a certain horizon. About 2 weeks, for the real atmosphere. Forever, if you want bit-perfect accuracy. So when you watch this shape, you are not looking at randomness. You are looking at determinism with a memory that is too small to hold the future. The butterfly is what predictability looks like when prediction is impossible. There are other strange attractors. The Rossler system is a single twisted ribbon. The Aizawa attractor is a fingered cup. Halvorson's is a triangular knot. Each one is a different way that simple rules can fold space into something that cannot be untangled.